A physics student pushes a box along a rough horizontal surface with a constant horizontal force of 120 Newton. The mass of the box is 45 kilograms. The coefficient of kinetic friction is 0.20. Letter A, what is the acceleration of the box? Letter B, how far will it move in 2.0 seconds? Assume the box starts from rest. So again, the very first step is to identify all the forces acting on the box. That is our free body diagram. So let us identify all the forces. Always remember na meron talaga tayong weight, and that is always directed downwards. So this is the weight. Next, there is a surface, tama? So that means that surface exerts a force on the box. So that means that surface exerts a normal force Fn. Ano pa yung present dito na force? We have, of course, an external force, and that is what we call the applied force. And what is the direction of the applied force? The direction is going to the right. So papunta tayo sa right ang applied force. Ayan. Next, do we have frictional force? Take note, there is a mention of the coefficient of friction. So if there is a mention of a coefficient, then that would automatically mean that there is a presence of friction. Kapag ka may makita ka na coefficient sa problem, then of course, mayroong frictional force. Now, what is the direction of our frictional force? It will be in the opposite direction of the motion. Saan papunta yung box natin? Papunta siya sa right. Tama? Kaya dito, mali mo siya i-push. So that means the friction must be directed to the left. Papunta dapat siya sa left. Ayan. This is our frictional force. Follow? Okay, so let us simplify our free body diagram din, so that we will have a clear visual presentation of our free body diagram. So now we have weight, which is directed downwards. We have the normal force, which is upwards. We have the applied force to the right. And then we have the frictional force to the left. So are we going to identify the x component and vertical components of our vectors? No need, kasi walang angle. Hindi siya naka at a particular angle. So let us identify next the required variables dito sa ating problem. Ano-ano ba yung mga required variables natin? Una, required, yung given variables pala. A physics student pushes a box along a rough horizontal surface with a constant horizontal force of 120 Newton. So this 120 Newton is the force exerted by the physics student. Ito. Then that would mean that that is our applied force, 120 Newton. Okay, another given. The mass of the box is 45 kilograms. So automatically, mass is 45 kilograms. Now, kapag given si mass, then you can calculate automatically the weight. Kapag given si mass, di ba? Masolve lang na diretso ang weight. That is just 45 kilograms times 9.81 meters per second squared. And that will give us a weight of 45 times 9.81. 441.45 Newton. Remember the number of significant figures? Dalawa lang. Pero wag mo na i-round off. Hindi pa yan final answer. Initial pa yan. Next, ano pa yung given? The coefficient of kinetic friction is 0.20. Coefficient of kinetic friction is 0.20. Next, ano pa yung given dito? What is the acceleration of the box? How far will it move in 2.0 seconds? So time is 2.0 seconds. Assume that the box starts from rest. So ibig sabihin our initial velocity is 0 meters per second because it starts from excuse me, from rest. So ito yung mga given values natin. Now let us identify what are the required variables. Dapat white na lang yung required natin. Ano ba yung hinahanap dito? Una, what is the acceleration of the box? Acceleration. Saan siya mag-accelerate? Is it along the Y? Vertical ba yung pag-accelerate niya or along the X? Horizontal. Of course, it will accelerate along the X. Kasi nga, i-push lang nimo sa X direction. Hindi man yan mag-move up or down. It will move to the right. So, A sub X. Letter B. How far will it move in 2 seconds? So, that is displacement. Of course, it is also along the X. Mag-move siya along the X. Questions? None? Okay, let's proceed. So for letter A, ang hinahanap natin is the acceleration along the X. Is it first law or second law? First law, if there is no acceleration, kagaya dito kanina, wala siyang acceleration, so that is first law. Pero sa problem na ito, there is already acceleration. Kasi yun ang hinahanap natin, acceleration. So ang gagamitin natin is the second law of motion, which is law of acceleration. And that is summation of forces must be equal to mass times acceleration. Do you follow? So yun yung kaibahan. Kanina, ang ginagamit natin is summation of forces must be zero. Bakit? Because this is first law. Walang acceleration. Dito, meron na siyang acceleration. So that means summation of forces must be MA. Second law of motion. Do you follow? Now take note, this is along X. So lalagyan mo lang ng X. AX and then F sub X. Okay? So let us identify all the equations or all the forces along the X. Tingin ka doon sa free body diagram mo. Saan dyan yung along the X? Unang variable along the X, unang force along the X, we have FF. Tama? Kung i-blue na lang ako. We have FF, which should be negative because it is directed to the left. Plus, ano pa yung forces along the X natin? We have FA, which is directed to the right. Tama? So positive. Okay lang yan. Is equal to mass times acceleration along the X. Nakuha? Okay. So let us substitute or i-identify muna natin kung ano yung daga na kung mag-admit na maliit eh. Ano ba yung equation natin for frictional force? Remember our equation for frictional force? It is mu K, because this is kinetic man ang given, times Fn. Follow? This is the equation for frictional force. Remember the discussion. Plus, Fa must be equal to mass times acceleration along the X. So check natin if all the variables are present. Do we have mu K? May mu K ba tayo? Yes, we have mu K. Do we have Fn? May Fn ba sa given? Hello, walang Fn. Do we have applied force? Yes, meron tayong applied force. Do we have mass? Yes, meron tayong mass. So that means we can solve this, pero wala pa tayong normal force. So paano natin ngayon kukunin si normal force? Sino yung makaremember paano kunin si normal force? Paano natin i-identify si Fn? Wala tayong Fn sa given.
Since horizontal man ni sir kay normal force is equal to weight.
Very good. So since horizontal ang surface natin, normal force is equal to the weight. So ang normal force dito present pala yan because that is equal to the weight. Very good, Karen. Again, if it is horizontal. Sir, what if hindi horizontal? Go back doon sa may example ako na hindi horizontal. Paano kunin yung Fn kapag hindi horizontal? Now, horizontal siya, so that means Fn is equal to the weight. So let us substitute all our variables. Una, we have mu K times the weight. Kasi weight, pareho lang naman sila. Is equal to Fa is equal to MAX. Since ang hinahanap natin is acceleration, so we can just divide by M. We can divide this by m. Cancel? Cancel. Follow? Okay, so acceleration along the x must be equal to negative. Ano yung mu k natin? Our mu k is 0.20 times our weight. What is our weight? 441.45 Newton. Plus, what is our FA? Our FA is 120 Newton. Divided by, what is our mass? Our mass is 45 kilograms. Okay, so we can calculate that. What is 0.20 times 0.20 times 441? 0.20 times 441.45. That will give us a negative 88.29 Newton plus 120 Newton all over 45 kilograms. And that will give us what? That will give us 0.7047 meters per second squared. How many significant figures ang kailangan natin? Dalawa, kasi dalawa lang yun naman yung given natin. So that means our final answer must only contain two significant figures. And that will give us 0.70 meters per second squared. This is our final answer. Questions? Questions so far? Wala? Shall we proceed? Okay. Proceed tayo sa letter B. For letter B, ang hinahanap natin is the displacement, D. So anong gagawin natin? Anong gagamitan natin na equation? Remember our equations doon sa kinematics? We have acceleration is equal to velocity final minus velocity initial over time. Magagamit pa din natin yon dito. Abin nyo gumano na tato? Wala pa sa lintawan. Vf squared minus Vi squared. And then D is equal to Vit plus 1/2 AT squared. These are the equations. So saan dyan yung may displacement? So we cannot use this equation. How about ito? Meron ba tayong acceleration? Yes, meron na tayong acceleration. Meron ba tayong final velocity? Wala. So that means we cannot use this equation. How about this equation? Meron ba tayong D? Yun ang hinahanap. Meron ba tayong initial velocity? Yes. Meron ba tayong time? Yes. Meron ba tayong acceleration? Yes. So that means we can use this equation. So to solve for D, we will use the equation D is equal to Vit plus 1/2 AT squared. Hello? Okay, now take note, our initial velocity is 0. Tingnan yung given. Our initial velocity is 0, so that means this term can be disregarded. That will be 0. Any number multiplied by 0 is just 0. So that is D is equal to 1/2 times what is our acceleration? Our acceleration is already been solved, and that is 0.70 meters per second squared. Sir, ang gagamitin natin yung naka-round off na, hindi yung mayroong extra. It's up to you. Pwede yung naka-round off, pwede din yung mayroong extra. Kung gusto mo sure, itong may extra. Pero pareha lang yan ng answer. Try natin later. Pareho lang ba ng answer? 2.0 seconds squared. And that will give us, pila? That will give us 1.4 meters, but we need how many significant figures? We need 2 significant figures. So that answer is already correct. So D is equal to 1.4 meters. Yan. O, di ba? Dali ka kayo, no? Sir, sige daw, sir, ipakita daw, sir. What if ang gagamitin ko is yung exact? Sige. 1/2 times 0.7047 meters per second squared times 2.0 seconds squared. Remember, dalawang significant figures lang yan. And that will give us 1.4094 meters. Sir, lahi man lagi survey. Remember how many significant figures ang kailangan natin? Dalawa lang na significant figures. So that means that is actually 1.4 meters. Ayun, di ba? Pareho lang. As long as you follow the rules of significant figures, you will attain to the same number, the same answer.